Hello, this lesson is infinite geometric series. So the previous lesson was finite geometric series. That means we can count the number of terms that we're going to be adding together. It ends, it's a specific number of terms. Infinite means that the list keeps going on and on forever and ever, but we're still going to be able to add these numbers together, which is a little bit difficult to wrap your head around. How can you add an infinite number of things? So as an example to explain that, I have this geometric series. And if you take the second term divided by the first term, you can see that r is 1/2. We're multiplying by 1/2 every single time. So as we go down the line, the numbers get smaller and smaller and smaller and smaller. Well, if you go to infinity, at some point, the numbers are so small that adding them on doesn't make any difference anymore. So you can end up adding the numbers that have enough heft to them to make a difference and getting a sum, and it's mathematically accurate. In fact, the sum of this series is 2. And the formula for this really complex idea is actually a very simple formula. It's S equals A sub 1 over 1 minus R, with R being the common ratio. A sub 1 is the first term. So for this series, A sub 1, the first term is 1, over 1 minus 1/2 is 1 divided by 1/2, which would be 1 times 2, or 2. Let's look at another one. Evaluate the sum, and we have our series that goes on forever and ever. So to fill in the formula, we need R, which is the second term divided by the first term. 11 over 33 would reduce down to 1/3. Our first term is 33 over 1 minus 1/3. And if you get a common denominator, that would be 3/3 minus 1/3 is 2/3. So it's 33 divided by 2/3. Flip and multiply. 33 times 3/2 is 99 halves. Again, we want fractions. We don't want decimals. So if you take all the numbers that keeps going forever and ever and ever and ever and add them all together, the infinite amount of numbers, you get 99 over 2. But here's a little glitch. Let's look at this geometric series. The R value here would be 2. We're multiplying by 2 each time. So those numbers are going to get larger and larger and larger and larger. You're not going to have numbers that when you try to add them, they're so small they don't matter anymore. They're just going to keep getting bigger and bigger and bigger and bigger. When this happens, you cannot calculate the sum. So the rule is, if the absolute value of R is less than 1, we say that the series converges, and we can use our formula to find the sum. But if the absolute value of R is greater than 1, we say that the series diverges and it has no sum. So the series at the top here, 1 plus 2 plus 4, and so on, because R is equal to 2, and the absolute value of 2 is greater than 1, then I know that this one diverges, has no sum, it can't be calculated. So that's something we have to check for in every single one of these problems. In this set, we need to find R, first of all, to see if it can even be calculated. So R is the second number divided by the first. Since we're dealing with fractions, let's just go ahead and write them beside each other like this. Divided by the first, which would be flip it and multiply. The 2. And you can do some reducing down, or you can just go ahead and multiply it out. The top is negative 20,000 and the bottom is 8,000. And you could reduce that down to negative 20 over 8, or negative 5/2. So we need to check that the absolute value of negative 5/2 is positive 5/2. That's greater than 1. So this series diverges. There's no sum. It cannot be calculated. All of this also applies if your geometric series is in summation notation. So if we look at that, then we know we need the first term. So to find the, well, first of all, we need to see if r is greater than 1 or less than 1. So the number with the base with the exponent, the 0.4, that's r. And because the absolute value of 0.4 is less than 1, we know it converges. And we can keep going. A1 then would be whatever you get when you put a 1 in for the n. 7.5 times 0.4 to the 1 minus 1. 7.5 times 0.4 to the 0. Anything to the 0 power is 1. So it's just going to be 7.5. Filling in our formula then, we've got 7.5 over 1 minus 0.4. Now this one is already decimals, so we can just keep it decimals, and you get 12.5. Notice in the summation, there's an infinity at the top of the sigma. That's how we know we're dealing with an infinite geometric series and to use this formula. And the last one, when we check r, it's negative 3. The absolute value of negative 3 is positive 3. That's greater than 1. So this series diverges. It has no sum, and we can just stop there.